So this is the P2 from last year final exam, and this is a solved script by one of the students. We will look at it, and answering strategies will be discussed, and feedback will also be discussed. Question number one says that there is a car with the mass and the speed, and it's colliding with another van. Mass is given, and they both move with the velocity. So we are using the law of conservation of mass, law of conservation of momentum. So momentum before collision should be momentum after collision equal. So look at the questions, define momentum, product of mass and velocity. Now in the calculate momentum, we will be using m1 v1 plus m2 u2 equals m1 v1 plus m2 v2. So we know that the final velocity of both car and the van are actually v. So we will substitute v1 and v2 as v, and then taking v common, adding the masses gives you this, and then inputting the values, and then you substitute all the values, and then you calculate v3 like this. And then we are asked to calculate the kinetic energy. We will be using half mv square. The mass is given, and this mass is, if you look at it, so we have the 1100 and 3000. So this is the total mass. So we use this total mass, and then velocity is just calculated, is squared, and then putting all this in calculator and making sure that you're doing the right calculation, you should get this answer. Second question is the vector addition. So an aeroplane flying in this direction, which is north, with this velocity, this force, and then there is a wind force acting on it from the left. You have to calculate the resultant. So you take a scale. This student has taken 1 centimeter equals 4 kilonewtons. So he draws it like this: 9 centimeter line in north, 3 centimeter line in east direction. And then he does it by vector addition method, but you don't have to do that. If you know the Pythagoras, you can just input, because there is a 90-degree angle, you can input these values and you get the answer. And you can get the answer of the angle by inputting the tan inverse identity and putting perpendicular over there. But this student has done it using a graphical method, which is always acceptable, and it's actually good practice. B part, the acceleration is uniform. So it is asking how it is different from a non-uniform acceleration. The response here is that a uniform acceleration refers to where velocity is increasing at a constant rate. So if you look at the constant rate, it is a tick on the constant rate, that is 1 mark. And a non-uniform acceleration, the velocity is increasing not at a constant rate, rather it different. So another tick, that gives 2 points. The mass of the aircraft given, the acceleration is asked, so you use F is equal to ma, the mass, and A will be F force over mass. Force is calculated in the vector addition question, so you will use that. So you will pick the value from here. So this is the resultant force acting on the aircraft. And then using this, you will calculate the answer. So make sure you input it correctly. Make sure you use the K here the K was not used. Actually, it was used. The K is used here because it is 60K kilograms, but it wasn't just written. So don't be confused that 60 and 37 are divided. It is the K and K that are cancelled. The both stands for 1000. So kilonewtons, kilograms, 60,000 kilograms. The K are cancelled. 37.9 divided 60 gives you 0.36632, and that is your answer. Next question. Car approach traffic light. Light changes to red. I think we did this question yesterday, and it is the same type of question, not exactly the same question, same type of question, but that was for the thinking and braking distance, and now it is asking different things. So the car starts to slow down a short time after the light change to red. Determine the time between the light changing to red and car starting to slow down. So this time here, if you look at the graph, take a scale and check this on the time scale. This should give you this point. So if you look at the scale, between 1 and 2, there are 1, 2, 3, 4, 5 boxes. So each box is representing 2. It will be 1 and then 2 and 2, 4, 1.4 seconds. So this is 1.4 seconds. Second, what is uniform acceleration? We already done that. Rate of change of velocity is constant. And then it is saying that between 2 and 7 seconds, the acceleration is non-uniform. Why? Well, you look at the graph. You look at this graph, it is showing that there is a slight bump here. It's not a straight line. That's why the acceleration changed, and hence it is not uniform between 2 and 7 seconds. If somebody asks you the acceleration between 4 and 7 seconds, that is uniform, and between 2 and 4 seconds or 1.4 and 4 seconds, that is uniform. It is asking between 2 and 7 seconds. Carefully read the question and then answer it. So the line is not straight. And then it is asking the distance, so it is the area and the graph. So first part, second part, third part, the guy has done the calculations, and these three areas are then added together nicely. Make sure no mistakes are done in calculation. Make sure you do it. You do a lot of practice of these questions. So the area is not in meters squared. So that is the mistake, but it is given an advantage. Make sure you don't do this mistake. The area is always in meters. So it is the area under the graph. It is not the area of the length and width type thing. Question number 4, reading, and it is asking for how the reading is used to find the mass. Well, to find the mass, you just divide it, because the reading is in newtons, so you divide it with the gravitational acceleration. You don't have to do it here. You just explain how you will use the reading. So you write, to find the mass, you simply use the formula W is equal to mg. I have given some feedback here. So the answer is wrong, because mass is the reading of the Newton meter divided by D. Okay, so you should actually describe the reading only. You shouldn't give the general rule. Okay, so this is why he lost 1 mark, because of not writing this. Make sure you do this. So it is the same brick are used, and this is a moment question. So what is the principle of moment? Clockwise moment and anti-clockwise moment are both equal if the object is in equilibrium. So I guess 1 mark. And then determine the distance. So this is clockwise moment and anti-clockwise moment, the both. So if you look at this diagram, this way it will produce moment this way, which is anti-clockwise. It is its weight is to be fine. and the distance from the pivot is 30 centimeters. And then this force upward acting is producing a clockwise moment, and it is at 20 centimeters. So we use this 3 into 13 f into 20, and that gives you 4.5 Newton, and that is the reading. And then it says that a beaker is placed. So the beaker has water. Water has upward force on the block. So the apparatus is adjusted. You can see the distances. You can see the Newton meter. Why the reading on the Newton meter is less? You clearly see the reading is less. Don't see it here, but you will see it in practical. Because the water applies an upward force on the block, so the block's resultant force is decreased. This decreases the moment, and hence less moment is required to balance it, and hence the Newton meter is pulled upwards. What it's saying here, it is making a mistake. Let's see, it might be less due to weight of the rope. No. Also because of, well, actually, yes, weight of the rope is acceptable, but weight of the rope was already there. Also, because of the water, an upward upthrust force of the water reduces the anti-clockwise moment. So 1 mark is given of writing a few things, but not exactly. So the actual answer will be the upward force of the water reduces the anti-clockwise moment. That will give you 2 marks. This one, question number 5. There is a bench whose weight is 2000 newtons. It has all these details in the diagram. What you have to do is each of the 2 sports has an area of 0.04 meters square in front of the ground. Calculate the pressure. The pressure is force per unit area. The force is 2000 Newton. And the total bench. So both the legs will divide the pressure. So we have to multiply the area of the sport with 2. And this should give you this answer, which is correct. And then the center of the mass is 5.1 from the left and 0.24 from the right, from the front. Suggest one reason why the center of mass is in this position. It is because the bench is a geometrical shape and it's a regular shape. That's why center of mass is always at the intersection of the diagonals of the geometric shape. And then there is a numerical, but there was an error in the question, and that's why it was given marks. So hopefully you won't get this. Question number 6. A man with 80 kilograms standing in the lift. What is the weight? You just multiply it with 10, with 9.8 if it is given, otherwise 10. Make sure you use the data given in the question. And then you will be multiplying 80 with 9.4, 9.8 will get this answer. And then the resultant force on the man, if it is accelerating uniformly at this rate. So F is equal to MA, 80 into 0.5 gives you 40 newtons. And the force exerted on the man by the floor is, well, you look at the force that the upward force plus the weight of the man gives you the force that the lift applies on the man, because the man's weight is 784 and it is accelerating upward with the 40 Newton resultant force. So the total force that was 784 plus 40, and that was producing the acceleration. So the lift is like this. So it is accelerating, decelerating, total distance 8. Sketch the graph. So when it is accelerating, it will be a curve like this up to 4 seconds. So it will be like this. And then it will be decelerating. The curve will be like this. So it will be like an S type curve. It should start from 0, 1 mark. It should end at 8 seconds, 2 marks. It should have the S shape. That's 3 marks. Okay. Question number 7 is asking to, well, it is giving the density volume calculation. So there is a scale, there is a reading on the of the measuring cylinder. So it says how mass and weight are different. Well, the two things the student has written, mass remains same, weight change. Mass is amount of matter and weight is the force acting due to mass. How to determine the density and 4 points, and you know very well, we've done this a lot of times. You will be using this. You can read this. It's all very good. All the ticks means all the key points have been mentioned. First of all, mass of the measuring cylinder, empty cylinder, noted as M1, and then mass of the cylinder with water taken as M2, and then that is subtracted. That gives the mass of the liquid. And then we will note down the volume from the measuring cylinder, and then we'll use the formula density is equal to mass per unit volume to calculate the density. You don't have to calculate the density. You just write the process. Make sure you listen to this carefully. Otherwise, you will lose the mark. Here, you're asked to calculate the density using this data. You just put the values. Make sure you put them in the right way. Mass given goes in the mass place, then density goes into the density place, and that gives you the volume. The volume is this much. Okay, so make sure you use the correct units as well. It's cubic meters, so your answer will come in meters. So don't worry about 10 power minus 4 will be a small value. It is not a small value for the cylinder. Cylinder is only in, if you look at the cylinder, it is centimeters cube. Okay, the answer is cubic meters. That's why it is such a small number. If you convert it into centimeters, it will be a positive number. Question number 8, the horse, the two fences. Okay, so very good question. It is asking, draw and label the forces acting on the horse. So the weight of the horse acting downward as W. The guy lost the marks here. The weight of the man acting downward, this one. And then here, look at these arrows. These are the contact forces. 1, 2, and 3, and 4. 4 arrows here will be the normal reaction force of the ground on man and horse. Okay, so these two arrows give you 2 marks, and these arrows give you 1 mark. Explain how Newton's third law applies. Well, Newton's third law applies in this way, is that the Newton's law says every action has a reaction. Okay, and force F applies on the horse, and an equal and opposite force in the is exerted on the girl. Well, if I should have given more feedback here, because first of all, the force of the force F and W are applied on the ground altogether, and the ground applies equal and opposite force onto the ground. Next part, which is more stable and which is less stable, and which is of uniform. They both have the uniform density. Mark the center. So this mark should be here. Okay, this is the correct mark, but this mark shouldn't be here. It should be here, because if you cross these, the intersection will be here. So that's why he lost 1 mark. Explain why a wider base makes the fence more stable, because of the A wider base makes the sense more stable as more mass is distributed over large base area. Yes, it is correct. Very good answer. You can also write that a wider base gives is more stable because the center of gravity is lower for a wider base. That will be an easy answer. Now it is asking the kinetic energy, and this is the kinetic energy, and you have to calculate the speed. So put the kinetic energy, put the value of the mass, and calculate all this. This will be the speed. Another question about the same thing. You're given the height, you're given the potential energy and gravitational energy, and you're asked about the height. So is 1.4 meter above the ground. Calculate the maximum height above the ground of the center of mass during the jump. How high did he go? So you will be using the same strategy, same technique. You will be inputting the gravitational energy, mass, gravitational acceleration, and you will calculate the height like this. So come to the conduction and heat. Both glass and iron are both conductors. However, glass is poor conductor and iron is also a good conductor. Describe using idea about the particles, how conduction takes place in glass and in iron. So um, he gets all the marks. Okay, so he has his own response. You can write response. I can tell you the difference and the 4 points. Okay, so 4 points are aiming at two things. One is the atoms in the glass are vibrating. Okay, and there are no free electrons in the glass. The atoms in the iron and it has free electrons. So these two are the differences. Now it is asking how conduction heat takes place in the glass. The glass will get heat, but it won't transfer its heat all the way to the other end. However, because of the vibrating atoms do not get free electrons to take their heat. And in metal, in iron, the free electrons, when it gets heat, the vibrating atom will transfer heat using free electrons to the distant particles. So the iron will get heat throughout, conducted easily due to the free electrons. He has also done the same thing, but in different words. Now, the apparatus is showing there is water, there is point X, that is the liquid level, and it is provided heat. Okay, so the student lost marks here. It is asking the glass flask full of water is heated. Student is surprised when the liquid acts in the glass tube falls for a few seconds before it rises. So first it falls before it rises. Well, it falls because the first heat goes to the glass expands. When the glass expands, obviously the water level will go down. Then heat starts to going to the water, and then the water expands as well, and then it will go up. That's why. So secondly, describe how heat is transferred. It is the convection question. So first, the particles at the bottom get heat and they become less dense. They go up. Particles at the top are more dense. They go down, and that's how the heat the process continues, and that's how the heat transfers. Question number 10, a satellite is orbiting around Earth. The scalar and vector difference, you know very well. Scalar doesn't have direction, vectors have direction. We need to underline the vector quantities, which is displacement and force. So, he is losing marks in this question, so let's see. So it says there is a resultant force acting on the satellite. Explain how the motion of satellite shows that a resultant force is acting on it. Very tricky question. So look at this feedback. So I am giving feedback here that A resultant force is acting on it. Okay. So it is accelerating, which is only possible if, sorry, velocity is changing, so it is accelerating, which is only possible if a resultant force is acting on it. And that's the reason. Okay. And that's the answer. You can have your own answer, but make sure you answer the question that why resultant force is acting if the object is 10.1 is accelerated. State the cause of this force is the centripetal force, and this is the gravity. Okay, the cause of this force is gravity. The centripetal force is not correct answer because centripetal force is the force type of the force. The cause of the force is the gravity between Earth and the satellite. Okay. Question number 11. Very tricky question. Look at the question carefully. It's a door, an automatic door closer. So this is your door. This is an automatic door closer. We have done this question in class. So all this data is given. It says that at point X, which is here, the force P is acting, and the distance is given, and the force is also given. Calculate the moment of P about the hinge. Well, P multiplies 0.72 should give you 18. Now the door closes 90 degrees. Circumference is this much. Calculate the work done. Okay. So the work done, in the work done, you will be taking the quarter of the distance. Okay. So the quarter of the distance will be 1.14. And this distance is covered by the force of 25 newtons. So the work done will be multiplying this with this will give you some answer. And then here the last part, door opens, force F on the door. Also F, although F is larger, the door rotates about the hinge Y. So it is because of the moment of will be less, still less, even if the force is larger because of the distance. Okay, so that ends the paper. Thank you very much.